Good morning, students. Myself is K. Pradeep Kumar, working as assistant professor in Mechanical Engineering Department, MVR College of Engineering and Technology. Today's our topic is about supercharging and gas turbine plant introduction. See, coming to the first topic about supercharging, we can observe the diagram here about the supercharging, how it is going to be. See, we in the previous classes we have studied about the four-stroke diesel engine. See how, and in this class I am remembering about the four-stroke diesel engine, the working principle, we have studied in the previous classes. See here, this is the flywheel, this is the crankshaft. See, this is a bottom dead center BDC, and this is the top dead center DDC, TDC. The suction stroke here. Here we can observe the suction stroke. This is the supercharger which we are using here, and this is the inlet valve, this is the fuel injector, and this is the outlet valve. By using of all these components, we are going to do the working principle of diesel engine. See here, we all know, sir, the working principle of this diesel engine, that when the inlet valve opens, the air is going to be sucked inside the engine cylinder, and after compression, the fuel injector injects the fuel into the engine cylinder, where the heating is generated, and the compression has been taken place, and after compression, ignition takes place, and what are the hot gases produced are exhausted into the atmosphere by using of this outlet valve. See here, when see when the inlet valve opens, the piston moves from top dead center to the bottom dead center, whereas the air from inlet enters into the engine cylinder. When the air is going to be enters into the engine cylinder, the supercharger also forces the air into the engine cylinder. Means when the supercharger forces the air into the engine cylinder, here the efficiency of the engine, and whereas the work output of the engine is going to be increased, as the supercharger is going to forces the air into the engine cylinder. Means as the supercharger is forcing the air more than that of the sucking air into the engine cylinder, hence we are going to increase the output and efficiency of the engine. Means if we are having 100 we are going to suck 100 ml of air into the engine cylinder. Means if the supercharger forces more air, means the work output also is going to be increased here. Means the work output, whereas the work output and the efficiency of the uh, engine cylinder is going to be increased here. See here, we all know the four working process, that when the inlet valve opens, the air is going to be enters into the engine cylinder. At the time, the supercharger also forces the air or pressurized the force into the engine cylinder. As the supercharger forces the air into the engine cylinder, the output and the efficiency of the engine cylinder is going to be increased. Here we are using, as we are studying about the CA engines, the here we need the fuel injector for injecting the or atomizing the fuel into the engine cylinder for the complete combustion process. Hence, after combustion has been takes place, the products are the hot gases which has been developed are exhausted into the atmosphere by using of this outlet valve. This is what we are studying about the four-stroke diesel engine by using of the supercharger. When compared to the weight of the engine cylinder and the supercharger weight is less than that of comparing with all these four-stroke cycle in engine. This is what about the four-stroke cycle diesel engine with by using of the supercharger. See here, coming to the supercharging, that the process of increasing the inlet air or charge density in order to increase the power output of the engine is called supercharging. Means supercharging means nothing but of for getting the efficiency of the engine or for improving the output of the engine. What is the pressure of air we are forcing into the engine cylinder? Means here we can observe the supercharger is forcing the air into the engine cylinder. As the supercharger is forcing the air into the engine cylinder, the air is more than that of the air which should be taken. Means if we are giving more air into the engine cylinder, or if we are giving more pressure to the engine cylinder, see we are going to increase the efficiency and the power output of the engine. This is what nothing but of this is known as the supercharging. Means the process of increasing the inlet air or charge density in order to increase the power output of the engine is called supercharging. And the device which is used here, we are using the device is named nothing but of supercharger. See that the device used for increasing the pressure of air above atmospheric pressure. Means the pressure should be more than that of the atmospheric pressure is nothing but of a supercharger. Means the pressure which we are forcing the air into the engine cylinder is more than that of the atmospheric air. Means there should be some difference inside the engine cylinder and the atmospheric pressure. When the pressure difference has been maintained in the engine cylinder compared with the atmospheric air, then we are going to name that as the supercharger. This is what the definitions of the supercharging as well as supercharger. See, coming to the supercharging, hence we can observe the diagrams here. We are having the low density and high density diagrams here in the cylinders. See that the more air and fuel that can be packed in a cylinder, the greater the density of air fuel charge. Means in the high density we are having air fuel charge morely greater than that of compared with the low density. In low density we are having less fuel and less air. See the method of supplying air or fuel air mixture higher than the pressure at which the engine naturally aspirates by means of boosting device is called the supercharging. Means nothing but of which we are pressurizing the force into the engine cylinder should be more than that of the atmospheric pressure, or and which we are going to develop the engine efficiency as well as the output of the engine cylinder is nothing but of supercharger, which we are learning here about the supercharging. See here, coming to the types of superchargers, we are having three types of supercharger. That the supercharger is a pressure boosting device which supplies air at a higher pressure. See, I have shown you in the diagram that the work of supercharger is to supply with the high pressure of air into the engine cylinder is nothing but of supercharger is a device which is used for boosting or supplying air into the engine cylinder with high pressure. See here we are having three types named as centrifugal type, roots type and vane types. These are some of the types which we are used for the supercharger. See here we can observe the diagrams of supercharger here. See, inlet port, this is the casing, this is the rotor, and this is the outlet port, and these are the vanes in sliding vane compressor. Here inlet port means nothing but of the air which we are forcing, into the engine cylinder. Here this is the casing, means covering here. This casing means nothing but of a cover which the air should not escape from the engine cylinder to the atmosphere. These are the vanes which are lies on the flywheel here. This is the outlet port. After um, after getting of the output of the engine, the hot gases which are going to be appeared are exhausted into the atmosphere by using of this outlet port. See here, from the inlet port we are giving the pressurized air or high pressure air into the engine cylinder. When we are giving the high pressure air into the engine cylinder. See here, the air is compressed in between this casing as well as this rotor. See here in between these two, the air which has been entered has been splitted into two sides and hence compressed in between this rotor as well as into these in between the casing as well as in the rotor. In between the rotor and the casing, the air is going to be compressed and is going to give high pressure. As it is going to increase the high pressure, the efficiency of the engine and the output of the engine are going to be increased. After high pressure has been developed, the combustion has been takes place and the hot gases which has been generated are moves out through by using of this outlet port to the atmosphere. Hence we can observe here the diagram of roots blower. See here the inlet port we are having here. From the inlet port the air enters into this inlet roots blower, and by using of these two rods, see it is going to rotate. The roots are going to be, means nothing but of impellers are going to rotate in anti-clockwise direction, and this is the casing and these are the shafts. See these both are going, the impellers are both are going to be rotate in anti-clockwise direction. When the air going to be enters into these roots blower, the air is going to be compressed in between the impeller as well as the casing, and the air in between the impeller as well as the casing, the air is going to increase the high pressure, and the high pressure is going to be developed and increase the efficiency and output of the engine cylinder. This is what about the supercharger, how it works in different way by compressing the air and going to increase the high pressure and going to give the output and efficiency of the engine cylinder. This is what about the types of superchargers which we can observe here. See here, supercharging means nothing but of supercharging or boosting is the process of increasing the pressure. Means as I have told you, as I have shown you in the diagram that superchargers working is nothing but of sending the pressurized or high pressure air into the engine cylinder more than that of the atmospheric pressure. See, it increases the density of the charge induced into the engine cylinder, and it usually done with the help of compressor or blower. By using of the blower or compressor, the air which we are sending into the engine cylinder, it increases the density of the air. See here, the power required to drive the supercharger is usually obtained from the engine output. What is from the engine output only the power is going to drive the supercharger here. Thus, some of the gain in power due to supercharging is utilized for driving the supercharger. This is what about the supercharging. And the effect of supercharging are, see we all know the 5 points that we should maintain the volume, increases the volumetric efficiency of the engine by using of the supercharger or supercharging. See, increases the power output of the engine and reduce the engine size and weight. See here, maintains the power of aircraft at high altitude. See, provides a better mixing and also even distribute the charge in the engine cylinder. Increases the tendency of SI and decreases the same in CA engines. This is about the supercharger or supercharging which we have studied up to now. And coming to the next topic is about gas turbine plant. See here, we can observe here we are having four main components which we are using in the turbine power plant, that the compressor, the combustion chamber, the turbine, as well as the exhaust gas. See, these are the three which we are using here: the compressor, the combustion chamber, and the turbine. See here, the fresh air is going to be entered into the compressor, whereas the air is going to be compressed here and is going to develop the high pressure and temperature. When the air has been compressed, the air is going to develop the pressure as well as temperature. The temp with this high pressure and temperature, the air is enters into the combustion chamber. See here, we are adding heat here. We are supplying heat. See, we are supplying the fuel into the combustion chamber. As the air enters into the combustion chamber with high pressure and temperature, when we are supplying some heat or fuel into this combustion chamber, the ignition is going to be takes place in the engine cylinder. And after this, what are the hot gases? Are the air which is having high temperature and high pressure is going to be enters into the turbine, where some work done is going to be takes place in the turbine, and it is delivered to the generator for converting into electrical energy. Whereas the hot gases which are living the atmosphere, which are living here, moves to the exhaust gases and enters into the atmosphere. This is what the procedure of the simple gas turbine plant, how it works. See here, coming to the introduction of this gas turbine plant. See here, the gas turbine is an engine said to be the heart of the power plant, produces electric power. See here, this is the, see this gas turbine plant, or the gas turbine is the heart of the power plant, which produces the electric power. For generating the electric power, we are using such type of gas turbine. See here, by burning of gas or liquid fuels along with fresh air. By using the fresh air along with fuels, we are going to burn the air, and we are going to generate the electric power here. The fresh air performs two main functions in gas turbine. See, what is the air which we are sucking from the atmosphere is the fresh air. The fresh air which we are using is going to do two main functions in this gas turbine. The first function is that the fresh air acts as a cooling agent for various parts of the power plant. See here, what is the air which we are sucking from the atmosphere? The air which is inside the cylinder, engine cylinder, when compared with the atmospheric air, having the more difference in the pressures as well as the temperatures. The air which we are sucking from the atmosphere is having somewhat cold air, and this cold air, by using of this cold air, we are going to cool the different parts of various parts of the power plants, and gives required amount of oxygen for combustion of fuel. For doing combustion, we requires oxygen. As the air is enters into the engine cylinder with a cooling agent, as a cooling agent, it is going to give a required amount of oxygen for combustion of the fuel. Hence, the as we are getting the oxygen, we are going to make the combustion completely. See here, the gas turbine engine have application for aircraft propulsion. The gas turbine supplies power to run the compressor and the generator to power the auxiliary equipment. See, I have explained you here in the diagram itself that how the air enters into the compressor, and how the air has been compressed here, and how it gives to the combustion chamber the high pressure air and high temperature air. And here in the combustion chamber, how we are going to supply the fuel, and how we are going to generate the power output, electric power output. See here, the gas turbines can be applied as closed cycle in nuclear power plants. In nuclear power plant, the gas turbines is cycle is applied there. This is what the about the introduction of the gas turbine plant. And coming to here, simple gas turbine plant. The simple gas turbine plant works on compressor, combustion, and turbine. See here, the gas turbine is an engine said to be the heart of the power plant, produce electric power. See, this is what this is about the simple gas turbine. In a gas turbine, first of all, the air is obtained from the atmosphere and compressed in an air compressor. See, we can observe in the diagram that the air, fresh air, is enters into the compressor, and it is going to be compressed there. The compressed air is then passed into the combustion chamber, where it is heated considerably. See here, we can observe here combustion. When after the compressed air is enters into the combustion chamber, See here, the hot air is then made to flow over the moving blades of the gas turbine, which imparts rotational motion to the runner. During this process, the air gets expanded and finally it is exhausted into the atmosphere. A major part of the power developed by the turbine is consumed for driving the compressor. The remaining power is utilized for doing some external work, which I have shown you in the diagram, that the fresh air enters into the compressor and heat is supplied here. The combustion has been takes place and it is sent to the turbine, and this turbine gives some work output. And the hot gases are appeared into the atmosphere by using of these the exhaust gases are appeared are dispersed into the atmosphere. This is, and we are having some types of gas turbines or classification of gas turbines. The gas turbine power plants can be classified into two types as open cycle gas turbine plants and closed cycle gas turbine plants. See, coming to these open cycle gas turbine plant, here we are using the atmospheric air is charged into the combustor through a compressor, and the exhaust of the turbine also discharges to the atmosphere. Means, as I have shown you here, that the air, the fresh air, how it is enters into the compressor, it is going to discharge the hot or exhaust gases into the atmosphere. This is what about the open cycle gas turbine plant. As it is opened, it is going to be the hot gases which are developed is going to be exhausted into the atmosphere. Coming to the closed gas turbine, in this type of turbine plant, the mass of air is constant. Here the air is maintaining the constant or another suitable gas used as working medium. See, we are can use the working medium in a different way. Suitable gas is going to be used here in the closed cycle gas turbine power plant, and it is going to circulate the cycle over and over again and again. See here, this is what the classifications of the gas turbine, which has been divided into two types as open cycle gas turbine plant and closed cycle gas turbine plant. See, the about the open cycle gas turbine plant and closed cycle gas turbine plants, we are going to study in the detailed manner in the next coming classes. See here, the classification of gas turbine plant. The gas turbine power plants which are used in electric power industry are classified into two groups as per the cycle of operation is going to be done in two ways, as open cycle gas turbine as well as closed cycle gas turbine. See, this is what about the gas turbine plant, how it works. See here, how it is going to be work, and how it has been classified into. See here, this is what the components which we are using in the this gas turbine plant. The compressor, which is used for compressing of the air which has been sent into the compressor as fresh air. The fresh air is enters into the compressor, and after compression, this is the shaft connecting the compressor as well as the turbine. The shaft is going to be rotate here. See here, the compression has been take place, and the air, the compressed air is sent into the combustion chamber. In the combustion chamber, combustion has been takes place as the fuel enters into the combustion chamber, and the air is also be enters into the combustion chamber. Both the air fuel mixture is going to be enters into the combustion chamber, and the ignition has been takes place for completing the combustion process. And here, after completing of the combustion process, the hot gases are the hot gases which are developed or generated is enters into the turbine, and here the net work output has been done. We can observe here that the fresh air acting as cool air, and see here, this is what the compressed air is then passed into the combustion chamber where it is heated considerably. The hot air is then made to flow over the moving blades of the gas turbine. See here, the hot air which is developed here is moved to the hot blades inside the gas turbine. See here, moving blades of the gas turbine which imparts rotational motion to the runner. See, during this process, the air gets expanded and finally it is exhausted into the atmosphere. See here, expanded and the air, hot gas, air is enters into the exhaust into the atmosphere. A major part of the power developed by the turbine means some work output is going to be given by the turbine. A major part of the power developed by the turbine is consumed for driving the compressor. See, which supplies compressed air to the combustion chamber and the shaft. See here, a major part of the power developed by the turbine is consumed for driving the compressor. For driving the compressor, see here, for driving the compressor, the turbine, the major part of the power developed by the turbine is consumed for driving the compressor. The remaining power is utilized for doing some external work. This is about the simple gas turbine plant, and I hope you have understand about the gas turbine plant as well as the supercharging. See, once again I can explain you about the supercharging, that here the supercharger is used to force the air into the engine cylinder. As the supercharger is forcing more air or pressurized force into the engine cylinder, the efficiency of the engine cylinder and the output of the engine cylinder is going to be increased here. This is what nothing but of the supercharger. And definition of the supercharging means nothing but of the increasing the inlet air or charge density in order to increase the power output of the engine is called as supercharging. And here the device used for increasing the pressure of air above atmospheric pressure is also called as a supercharger. This is what about the supercharging, and these are the types of superchargers how we are using here, and the types centrifugal type, roots type and vane type. And we have observed here the diagrams how the air is entering into these um, vane compressor. See, this is the vanes in between the uh, vanes and the rotor. So the air enters into the sliding vane compressor. In between the rotor as well as the casing, the air is going to be compressed and is going to give hot gases here. Here also in the roots blower, the air is going to be entered into the roots blower, and here in between the lobes are the impeller and the casing, the air is compressed and is going to give high pressure and high temperatures and are going to be sent into the atmosphere by the exhaust. See, means after compressing the air, hot gases which are generated is sent back to the out by using of this outlet port into the atmosphere. These are the types of the superchargers how we are using here, and these are the effects which are making for the supercharging, that here the power output of the engine increases the power output of the engine and reduces the engine size and the weight of the supercharger. See here, increases the volumetric efficiency of the engine, maintains the power of aircraft at high altitudes. At high altitudes also, we are going to maintain the power, and provides a better mixing and also even distributing of the charge in the engine cylinder. See here, increases the tendency to detonation in case of SI engines and decrease the same in CA engines. This is what we have studied in this unit about the supercharging and gas turbine plant introduction. In the next class, we are going to study about the types of gas turbine plants, or the classification of gas turbine plants, open cycle and closed cycle system. This is what we have studied here. Thank you, and if you are having any doubts, please contact me or mail to the mail ID which I have told you. Thank you.